Alright, so we're going to learn about one more rule for probability. It's kind of like I like to call it the OR rule, right? What happens if you have one event or another event, right, as your desired outcome? So let's first talk about, we talked about events being independent or dependent, and I told you that you can also say that they are mutually exclusive. In some cases, right? And now we'll figure out what cases that's always true for, right? So we're talking about dependent or independent. We're talking about one probability affecting another, right? But it's also going to be the case that if two events are not mutually exclusive, you're also going to be the case that one probability is not. We got a couple of Venn diagrams here, right? And I don't know what's going on with this, but I really like this picture to look like this. Should look like this, right? I don't know why there's a little weird thing there. Should look like that, right? And what's going on in this little shaded area, right, is A and B occurring at the same time, right? I'm not sure what happened with this drawing, but it ain't. Tell that drawing should listen. Alright, so if event A if event A is it is a cat, right? And event B is it is a dog, right? This makes sense, right? There is no one thing, right, that is both cat and dog, unless it's cat dog. So that would be cat dog right there. Okay, this example's okay, I guess. When I was looking through it, I was like, yeah, I guess it's alright. Are these events mutually exclusive, right? So is it possible to roll, and we're talking about one die, right? One die, right? Is it possible to roll a 3 and a 4 at the same time? It's essentially what this is saying. It took me a little while to parse it out, because I was like, wait, are we rolling 2 dice? Or what's happening with this, right? But what we're really saying is, if you're rolling 1 die, is it possible to roll a 3 and a 4? And of course, you can. Okay. I think, I don't know. Anyhow, I felt like it was a better solution, right? A better explanation is to say that if you're rolling 1 die, you can't roll both a 3 and a 4, right? That's what this thing is saying. In a little, I think, better terms. Okay? Why not? Okay. Why not? Alright. Hey, are these 2 events mutually exclusive? You randomly select a male student, and you randomly select a nursing major.
He could be a male nursing major.
Heck yeah. Heck yeah. This is not 1940. So, maybe in 1940 those 2 things would be mutually exclusive. Where they only allow females to be nursing. So yeah, same thing what we said. Here we go. Let's try some more. Here we go. Event A, you randomly select a jack from a standard deck of cards. Event B, you randomly select a face card from a standard deck of cards. Are those two things mutually exclusive or not? Well, because a jack is a face card, then if you pull a jack, then you have indeed pulled a face card, in which case, right, those two things do overlap, right? So if you were to draw a Venn diagram of this thing, right? And seriously, if you are stumped on these, you can always draw a Venn diagram. Okay, so this is a jack. And then you have a face card. Well, these are all the jacks in the deck. Right? And that little overlap, that's all the jacks in the deck. Alright, hey, we randomly select a 20-year-old student, and we randomly select a student with blue eyes. Is it possible that we select a student that is both 20 years old and has blue eyes? Heck yeah, so these are not mutually exclusive. These are not. This one is not mutually exclusive. Okay. We randomly select a vehicle that is a Ford, and we randomly select a vehicle that is a Toyota. Is it possible that we selected a vehicle that is both a Ford and a Toyota? There is not a Toyota. Ford Yoda? No. So these are mutually exclusive. Alright, so the reason that we're doing this is we have to determine whether, so we have two rules for, like, if one event occurs, the probability that one event occurs or another event occurs, right? And we have to decide if these two events are mutually exclusive, because if they are, we're going to use one formula, and if they aren't, we're going to use another formula. And so these are the formulas that I'm talking about. Alright? So, we're going to use this one for events that are not mutually exclusive, okay? So this one, if they're not. If they are, we get to use this one, okay? These are formulas in Portantes. Alright, so hey, let's go ahead and use this additional one. Alright, so we're going to find the probability that a card is a 4, or it's an ace, okay? So, I would like to say ace, alright? So, first of all, let's determine, are these two events mutually exclusive? Is it possible to draw a card that is both a 4 and an ace? Plus, it's impossible, right? So these two events are mutually exclusive, which means that I can say that, and I like to write it like this. So we are going to be using this one, right? Since they're mutually exclusive. And I'm actually just going to go ahead and drop this because this one actually looks really nice. This is actually a very good picture. It's a nice picture, right? In your deck of 52 cards, right? These things are all the things that are 4s. These things are all the things that are aces. None of those things overlap. There are no things that are both 4s and aces. And so if we look, what's the probability that it's a 4? Well, there are 4 out of our 52 selections, our 52 choices. And there are 4 aces out of our deck of 52, right? Just go ahead and calculate it. Alright, so how about the probability of finding of rolling a number less than 3 or rolling an odd number? Alright, are these things, are they mutually exclusive? Is it possible, in other words, is it possible to roll a number that is both less than 3 and an odd number? Yes. And I guess if you're counting that 1 is odd. I don't know, some mathematicians like that. Alright, cool. There's a really nice, I think there's a really nice picture again on that. I'm actually looking at their solution. Alright, so this is a nice solution. I'm not sure why there's this thing here. It's nicer like that. Right? Okay. So they are counting 1 as an odd number, right? So if that's true, essentially what you're doing is, right, the and, right? So all of the things that are less than 3 and odd, right? They're just this 1, right? So what's the probability that it is less than 3 and odd? There's only 1 out of 6, right? So that's what this is. So essentially what this formula does is it's subtracting that little overlap piece, right? Since you're just interested in one or the other and not the case that they have the 2 in common, you gotta subtract this little overlap piece. That's what that formula does. Alright, let's see. A die is rolled. Let's find the probability of rolling a 6 or an odd number. Okay, so the first thing we need to decide is it possible for me to roll a 6 and an odd number at the same time?
No.
No. So that means that I can use the rule that tells me that the probability of A or B is equal to the probability of A plus the probability of B, which turns out to be, let's see, if A is rolling a 6,
It'll be 1 6.
Yep.
It'll be 6, right?
Odd numbers, yeah, because we have, 1, 3, and 5. So there are 3 of those exactly, 3, 6, which is going to be 4, 6. Go ahead and simplify this actually. 2/3. With your point. Calculator. Yeah, today. I don't know why I don't trust myself. So approximately 0.66. All right, number 2 is more complicated. What is the probability that you select a card, and that card is a face card or a heart? First of all, is it possible to pull out a face card that is a heart?
Yes.
Definitely, right? So that means they're not mutually exclusive. So that means that we have to subtract what the things that they have in common, right? So in other words, we gotta use this formula that says that the probability of A or B is equal to the probability of A plus the probability of B minus the probability that it's A and B.
when you say P, the probability of A and B, like you're just multiplying them?
No. We have to find all of the things that are A and B. So we have to say, what's the probability that you pull something that is both a face card and a heart, right? So we have to actually think about how many things in the deck are that, right? So I feel like maybe drawing a Venn diagram. Let's see, we don't have one drawn for ourselves. So oh my God, and we're saying wow, okay, cool. Sorry, there's a typo on the slide, it threw me off. Hey, sorry, if you did copy this down, that should be a minus sign, that's not correct. I think this might be right, because even though they put a plus sign over here, it looks like we've got it right. We've got a minus sign. So let's talk about this, right? It's there, right? So we're saying that there are 12 things, right, in the deck that are they're face cards, right? And we're going to add that to the number of things that are hearts. There are 13 hearts. And we got to subtract the things that are uncommon, right? Face cards and hearts that, right, the Jack, King, and Queen of hearts, right? So there are 3 out of the 52 that are those things. Hey, good. All right. So, and if you were to put that in your calculator, you could just put this in your calculator. Let's talk about how we want to put that in our calculators as well. All right. So we can just hit our calculator button to get this there. So we got 4 divided by 52 plus 3 divided by, oh my bad, that was not 3, it should be 13, and it should not be 4. Yeah, for sure. So I got that was 12. Not sure where I got the 4 from, divided by 52 minus 3 divided by 52. And you guys remember, we do not want, I mean, that's great. It kind of makes a little more sense, though, to have a decimal. So if I just put a decimal in my numerator, there we go. And that should work. Okay. Hey. Alright, so now we got a table. And we're going to figure out some probabilities. So we have the volume of sales and number of months from which the sales are represented for each sales level. Let's find the probability that the sales representative will sell between 75,000 and 124,090, except so less than $125,000, right? Between $75,000 and less than, or sorry, so between $75,000 and $125,000, not including $125,000. So what does that look like? Here, where are we at? So we're looking at these two right here, right? So how often does that occur? How many months has that occurred? It has occurred 16 months out of his total. Out of the total months, I guess he's been a salesperson. Or during the past 3 years, I guess. Alright, so we're gonna have to add it up, right? What's our total possible outcomes? So out of all of these months, 16 of these, he actually did hit that goal. So we got to total this up. So I'm just going to count 10, 15, 20, sorry, I got 25. And then 36. 36. Oh yeah, there are 3 months. So that makes sense. 36 total months. 16 of them were successes, or our desired outcome. So remember our probability? Interesting. Okay. So it's going to be 16 out of 36. Just want to point out that that's the same thing as saying, right, that either he sold between 75,000 and 99,999, or sold he sold that, or he sold the probability, the same thing as the probability that he sold between 100,000 and 124,900. And if we add those up, we're going to get the exact same probability. Just kind of shorten it up. What is that going to turn out to be, approximately? Or maybe it's exactly, let's see. 16 divided by 36, or approximately 0.4. And there's the solution. There you go. Okay. So it looks like we have another set of mutually exclusive events. And this one's going to shake out. Oh, okay. What's the solution? Next slide. It's going to work the same way as the previous example. I don't think we need to do 2 examples like this. I think that's good. We're going to add the 3 and the 5 months out of our total, which is 36. Let's do something more interesting. Here we go. So a blood bank. It's good. They should catalog types of blood because it's not good to get the wrong type of blood if you need a blood transfusion. So the result is, I don't know, what is the result? You die from that? Yeah? I would assume that should probably kill you because it's worthless to your 3 body count. Alright, so what's the probability that the donor has type O or type A? Okay? Type O or type A from all of these, right? So it's not a given or anything like that, right? So this is our total possibility. Okay, do we have any overlaps? Is it possible to select someone that has both type O and type A blood? There's no way, right? You're either one or the other, right? So, and it doesn't matter. It does not matter what all this Rh positive, Rh negative, right? They've not mentioned it, right? So these are all the people that have type O blood. These are all the people that have type A blood. So what we're going to be looking at is 184 over 409 plus 164 over 409. We can put that into our handy dandy calculator and get a probability. 184 plus 164, all divided by 409, turns out to be approximately 0.85. And that's just a solution. Okay, same thing that I wrote in different. No, it's the same thing. Okay. Hey. So again, it's the same thing, same setup, right? A donor is selected at random. What's the probability that donor has type B or type AB blood? So type B, that's these guys, right? Oh, my bad. My bad. Oh, this, right? That's type B. Type AB is the 16. So for number 1, we would just be looking at 45 over 409 plus 16 over 409, which I believe is probably calculated below, so I'm just going to cheat rather than get my calculator. It should be 0.149 approximately. That wasn't the interesting one. The interesting one is number 2. All right? The probability that the donor has type O blood or is Rh positive. Okay, so we gotta parse this out a little bit. All right. Does you gotta think to yourself: is it possible that the donor that you select both has type O blood and is Rh positive? Are there some people like that have type O blood and are Rh positive? For sure, it's all those people, right? Well, oh, I circled the A guys, my bad. These guys type O and Rh positive. So we've got to exclude those because we're not interested in the ones that are both type O and Rh positive. We want only type O or, right? So those guys do not count. All right, so how about the people that are type O? We've got 184 of those, right? And how about the people that are Rh positive? That's all B's, right? We got to subtract the ones, and we got to subtract the others. So let's see what they got for first calculation for that. We got 0.910.